Let's look at another kind of displacement reaction. So here we are going to have a metal that will take oxygen from the oxide of a less reactive metal. So for example, if you have zinc reacting with copper oxide, so this is a metal oxide and it contains copper, and copper is less reactive than zinc, which means that zinc is going to be able to take oxygen from copper oxide. So you're going to have the formation of zinc oxide, and copper is going to be left all alone without any oxygen bound to it. So in this reaction, the more reactive metal has been able to take oxygen from an oxide of a less reactive metal. Now when we look at this reaction, zinc has gained oxygen to form zinc oxide, and copper oxide has lost oxygen to form copper. Now the gain in oxygen, this is called oxidation, and loss in oxygen, this is called reduction. So when we look at this reaction, we find that here we have an oxidation reaction, and that here we have a reduction reaction. So zinc here is causing the reduction of copper oxide. So copper oxide is going to get reduced to copper. So it's going to undergo reduction. So it's the zinc that is causing the reduction of the copper oxide. So we can say that zinc causes reduction of copper oxide to copper. So this is a reduction reaction. So a more reactive metal, here this is more reactive metal, will cause the reduction of a less reactive metal oxide, and it's going to give you the less reactive metal. Now in this reaction we have both oxidation and reduction, and it's called a redox reaction because we have both oxidation and reduction. So red is for reduction, ox is for oxidation, so you have both of them in this reaction. But the more reactive metal is causing the reduction of the less reactive metal oxide, and it's going to give us the less reactive metal as a product. So zinc displaces copper from copper to oxide. The balanced chemical reaction is given here. Now for this reaction to occur, we need a source of energy, and this source of energy is given by magnesium ribbon. And magnesium ribbon, when it burns, you have seen before that it burns with a dazzling white flame. This dazzling white flame means that there is a lot of heat and a lot of light that is given off, and this energy is used to trigger the reaction between zinc and copper, and this is called a thermite reaction. So here you have the magnesium ribbon that acts as a fuse that is going to provide the sufficient energy to trigger the reaction between zinc and copper to oxide. The sand here is a form of safety to prevent the large amount of heat from affecting the surroundings. So this is another kind of displacement reaction.